show that every convergent sequence is bounded. So now given xn, let xn be any let xn be any convergent sequence converging to L, and we want to show that our claim is xn is bounded sequence. Now when we said a sequence xn is bounded, if it has a lower bound as well as upper bound, that is a sequence xn lie between m less than or equal to xn less than or equal to m for every natural number n. If this is true, then we can say that a sequence xn is bounded. Now since xn is convergent sequence, since xn is convergent sequence and converges to what? L, this implies limit n tends to infinity xn is equal to what? L. Limit exists. Okay, so from the definition of limit, if we take any epsilon greater than 0, okay, there exists a positive integer m such that here we take epsilon is equal to 1. For this epsilon, there exists a positive integer m such that xn minus L is less than 1 for every n greater than or equal to m. Now say this is equation number 1. Now from absolute value function, we know that some basic concept, that is first basic concept, we know that the mod of a, which is same as mod of a minus b plus b, we add and subtract b, which is less than or equal to mod of a minus b plus b. Now since c plus d, we know that as a triangle inequality, c plus d less than or equal to mod of c plus mod of d. So if you apply this result, here we get mod of a minus b less than or equal to mod of b. From this, if we take this mod b to left hand side, we get mod of a minus mod of b less than or equal to mod of a minus b. So if we apply this for a is equal to xn, and b is equal to L, we get xn minus L less than or equal to xn mod of xn minus mod of L less than or equal to xn minus L. Okay, so this equation 1 becomes we can write it as xn minus L is less than or equal to mod of xn minus L less than 1 for every n greater than or equal to m. Okay, from this we can write xn minus mod of xn minus mod of L less than 1 for every n greater than or equal to m. Since a less than b less than c implies a is less than c, we use this. From this we can write mod of xn is less than 1 plus mod of L. If we take here lambda is equal to 1 plus mod L, then we can write, if we put lambda is equal to what? Well, 1 plus mod L, then xn is less than lambda for every n greater than or equal to m. Here also for every n greater than or equal to m. And therefore each term of the sequence xn, from this we can write, that is, if we solve this inequality again, we know that if mod of x is less than a and a is greater than 0, from this we can write minus a less than x less than a. Okay, if we use this property, Okay, if we use this property for here, we get minus lambda less than xn less than lambda for every n greater than or equal to m. So from this equation, from say this equation number star, from star we can conclude that each term uh, each term of sequence xn, each term of sequence xn except x1 x2 xm lie in interval minus lambda and plus lambda. So here if we take m is equal to maximum of mod of x1 mod of x2 mod of xm and lambda, from this then we can say that mod of xn less than m for every n greater than or for every natural number, not n greater than m. From this we can write, okay, from this we can write xn less than or equal to m for every natural number n or every positive integer n. And therefore now since xn is less than m for every natural number n, we can conclude that xn is bounded sequence, and therefore every convergent sequence, from this we can say that every convergent sequence is bounded. But converse is not true, converse is not true converse is not true. That is, not every bounded sequence is convergent. For example, if we take xn is equal to minus 1 raised to n, that is, if we write the few terms of the sequence, we get minus 1 1 minus 1 1 minus 1 1. Okay, so xn is lie between minus 2 less than or equal to xn less than or equal to 2. Each term of the sequence lie between minus 2 and plus 2, and therefore xn is bounded sequence, but xn is not convergent, since as limit n tends to infinity, xn is equal to 1 and minus 1. Okay, if n is even, then it is equal to 1, and if n is odd, then xn is equal to, this is equal to, if n is even, and this is what, n is equal to what, odd. So this sequence xn is the limit of this sequence is not unique, and therefore xn is what, xn is divergent sequence. And therefore from this we can conclude that xn is bounded but not convergent, it is not convergent. Okay, so the converse of this theorem is not true.